I'm going to talk about the new Java release train. As you might know, things have changed there. In the past, it has been like one release came out, and then you have had like 5 or 10 years to migrate to the next Java major release. And there has been a significant change in this. And this talk tries to look at what are the challenges that are arising from this change. And my name is Benedikt Ritter. I'm a senior software engineer at Gradle, the company that builds the Gradle build tool that you might know. And I've been working on the Apache Commons project for a long time. And so when you've been at the keynote, Lars said that the Jakarta project was actually one of the first top-level projects, and Apache Commons was formed inside Jakarta, so it's a really old project, or one of the oldest projects. And it's a project that's about maintaining a set of reusable Java libraries. So we have to deal with all these challenges like maintaining backwards compatibility and stuff like this. And so we are impacted by the changes to the release model of Java. And I mean, I haven't been around when it started in 1999. I was in elementary school back then, but I've been working on the Apache Commons for, I think, 7 or 8 years now. So some more about me. I do a little podcast. It's actually a German podcast about IT. So if you speak German and you're interested in podcasts, then just give it a try. It's like a conversational thing between me and a colleague, and we're discussing various topics. So yeah, and of course you can follow me on Twitter. I usually only tweet about tech-related stuff, so no cat pictures or anything. Just what I find interesting during my journey through the IT world. Okay, so with that, let's have a look at the agenda. So I would like to give you an overview over the past and the current Java release strategy and the roadmap and how they are dealing with things at the moment. Then I'd like to talk a little bit more in detail about Java 9, because that was like a major ripple through the whole ecosystem because of some new features that were introduced there, and I'm going to talk about what that meant for libraries like Commons Lang, for example. And then I have a few slides summing that up and going into the challenges that I see there, and yeah, then we can discuss how we want to deal with that. Okay, so let's have a look at the Java release policy, how it has been, and how it's now. So this is actually a list from Wikipedia that lists all the major Java releases on this page up until Java 8. And the next slide will have where we are now. And if you look at the release dates and the end of public updates dates, there, in the beginning, that it was like, okay, every year there was a new release. I mean, they were pushing this platform, so they had to do a lot of releases. But then it got slower and slower. So, for example, from Java 1.4 and Java 5.0, it was 2 years then. And then up to Java 6, it was again 2 years. And then I see I'm missing the year, actually. Java 7, when was that? I can't remember. Sorry? 2010. 2010. Okay, thank you for that. And as you can see, there was always an overlap between the release, the end of public updates, and the next release. So you could stay on the last version and still get updates, and then have a look into the next version and think about whether it makes sense for you to adopt it or come up with a strategy. Find out what you have to change in order to get your application running on the next release. And actually, up until Java 8, there was, most of the time, there was not a lot to do for you, because Java was developed in a backwards compatible way. So they only added new APIs and new features. They never removed something. So when you wrote something for, let's say, Java 1.2, you could be sure that it would be running on Java 6 probably if you're not used internal APIs and stuff like that. So Java 8 is one of the current LTS releases. That's why it's marked in yellow. All the red stuff is already out of support. So Java 8 is currently LTS release, and the end of public updates was in January 2019, although there are new JDK builds now arising, like Corretto from Amazon or Adopt JDK and Zulu. And depending on which JDK build you use, you might get more free updates, or of course you can always buy the commercial update support and then get an extended period of updates. So this is what it was in the past. We had this Java major version that brought some cool new features that we could use. For example, Java 5 was very famous because it brought generics, which was like a huge thing, but it was easy to adapt. You didn't have to change your code. You could if you wanted. And now let's have a look at how this release train has changed in the future. So there are new, some more colors now. So red is still the releases that are out of support, basically. Yellow is again the current LTS release that is supported. Green is the current, so the most current major version, so the last release that's still that's like active. And orange is what's currently early access. So Java 14 is early access, and blue are the future releases. So if you take a look at this slide, you can see that something very significant changed here. And this is if you look at the release dates and the end of free public updates dates and compare that to the next line. So the model now is if you have some release that's not an LTS release, then you get the release, for example, for Java 9 in September 17, and the end of public updates is March 2018. And that's also the date when Java 10 is released, so there's no overlap. Okay? So in the past, we had this like 4 years of time to migrate, and now there is, for those releases that are not LTS releases, there's no overlap anymore. And that will be becoming interesting when I go about how they are changing the APIs now. Yeah. So we still have these LTS releases that are supported a little longer. For example, if you look at Java 11, the end of public updates is in 2022. And the next LTS release to come is Java 17. And that is planned to be released on September 2021. So there is like 1 year overlap. If you say, okay, I use this LTS release, and then I'm just waiting for the next LTS release so that I have like this little overlapping time where I can migrate things. So this might be like a good strategy, I guess. Oh, sorry. But something else changed there with Java 9, and that is how they handle breaking changes. As I said on the first slide, they never introduced breaking changes between JDK 1.0 and Java 8, at least as far as I know. Not in the public APIs, maybe in some Sun internal whatever APIs, but not in anything in the Java namespace. So now they have a new policy because they want to move faster and get rid of old stuff. So they say, okay, we will mark things that we want to get rid of with deprecated. So a new deprecated annotation has been introduced that has some that has some more features. For example, you can say, okay, it is deprecated and marked for removal. Then you have a Boolean value and can say, okay, marked for removal true, so that people looking at that API know, okay, this is going to be removed eventually. And the policy is that if they deprecate a feature in one major release, then they might remove it in the next major release. So let's think about that some more. So this basically means, just an extreme example, you are on Java 11 because it's an LTS release and you're not an insane person trying to update your Java runtime every half year, because that's a huge amount of work and testing. And then they say, okay, string, this class, it's not working anymore. Let's deprecate it and replace it with something much better. And they do this in Java 12. And remember, you're still on Java 11. And then they say, okay, I mean, remarked it. Everybody knows about it, that it's deprecated. So let's remove it in Java 13. And then you upgrade to the next LTS release, which is Java 17. And then, boom. So you don't know it. You have never seen that deprecation. You just go from the one LTS release to the next LTS release, and stuff doesn't compile anymore. So that's kind of a shift in the policy. I'd not say it's like the biggest problem ever, but as a Java developer, you have to get used to this, I guess. And don't you dare use Java EE, because that's a whole nother mess, to be honest. Because Java EE has been, so Java EE is like the enterprise edition with which lives in the Java X namespace. And this has been recently contributed to Eclipse Foundation. I don't know exactly when it was, but it's not too long ago. And they negotiated how they can develop Java EE in, under the umbrella of the Eclipse Foundation. And the result was, yeah, you can have this, but you must not use the Java X namespace. So basically, all those APIs, you know, from the Java X namespace, they are now migrated to the new Jakarta namespace. So that also doesn't compile anymore, and of course doesn't run anymore. So if you are using that, you will have some work, I guess, to stay compatible with the next Jakarta EE releases, actually. Jakarta EE is the name now of that. Okay. So if you're interested in just the deprecations that they introduced in Java 9, because I was thinking, can't be too much, maybe like 2 or 3 things that they deprecated. I've inserted a link here. It's a long list of things that they deprecated only in Java 9. So I don't know how much of that is marked for removal, but I think it's good to follow this. No matter what your strategy is, if you're saying, okay, I go with the flow, and sorry.
They also removed something for the first time in Java 9.
Yeah. Okay.
Something like 5, 6, 7 methods because they were not usable with or were not compatible with the module system.
Okay. Yeah, we get to that in just a minute, to the fun of the module system. Okay. So when I prepared that, I was thinking, okay, what the hell happened there? Why did they do that? And then I was looking some stuff at Wikipedia, and then I saw 2017 Oracle bought Sun. Might have something to do with that, I guess. So I think that they basically, so Oracle basically, I think they had a different strategy for what they want to do with Java, and that meant that they had to change the way Java was released in the past. So, I mean, it's their good right, because they bought Java, so they can do whatever they want. But it has an impact on all the users, and that's why we are sitting here together and discussing this. Okay, so let's have a look at Java 9, which I called Dawn of a New Age, because it was really like a ripple through the whole ecosystem. And my tagline is how one release broke an ecosystem, actually. But I'll get to that. So what I think the idea was behind Java 9, and it's not like documented somewhere, it's just what I think why they did it this way. they had the idea, okay, so we have to make Java cloud ready because we have all this cool shiny new cloud stuff and people are complaining about Java. So this is why I put an Apache colored cloud there. So we know, okay, we're talking about cloud now. And they said, okay, what's the problem with Java, or why is it not performing as good in cloud environments as other platforms? And I think they came up with, okay, we have this monolithic runtime that is kind of a problem because it's fairly big. So if you write a server application and you put the JRE under it, basically, it will ship with all the desktop code. So you will have AWT deployed to your server, although you're building a server application which doesn't make a lot of sense because you don't need that code, but it's deployed nevertheless. And this monolithic runtime, it leads to high memory requirements for Java applications compared to other runtimes, and considerable startup times compared to Go. For example, just an example, because that's what people always say, okay, Go is so much faster and it's so much easier to write applications, and yeah. And then you say to them, okay, how do we connect to our LDAP service? And they say, oh, I guess we have to implement it ourselves because there's no library for it. So, but nevertheless, I think that is what they had in mind. And then they said, okay, so here's an idea. Let's split up this runtime so we can make it smaller for cloud applications. And therefore, we really need to modularize our runtime so people can select which parts of the runtime they need. And therefore, we need to add support for software modules. So we have this clearly modeled. And therefore, we need to define a way for application developers so they can say which modules they actually need. So because if you write a server application and you want to have like this minimal runtime thing, you need to tell it somehow, or you need to define somehow which parts you need for running your server. So like JDK base, and I don't know how all the models, what the names of all the modules are, but I think this was basically the idea. So provide some support for letting applications define which parts of the runtime they need so they can strip down the runtime so it's smaller, it needs less memory, and it starts up faster. Sounds like a good idea, I guess. And they said, ta-da, here's module info. So if you want to go that direction and you want to work with the module system, want you modularize your application, you will need to introduce this module info file. And that's basically for the compiler to understand what's the name of this module, which other modules does it require, and which packages does it export. Yeah, and you just put it inside your project, and the compiler will help you to figure out how it works. And there's another very important change. So if you go down that road, you no longer work with a class path that you know from Java, -cp, and then you can pass all the jars you want to have on your class path to run your application. There's a new concept that's called the module path that is used for modularized applications. But of course, if you want to build a modularized application, everything you want to use, you're not only using like the runtime or the JDK. You're using all sorts of libraries and frameworks and, I don't know, persistence mappers and whatnot. They all need to be valid software modules so that you can deploy them into a modularized application. And that led to another problem, because Java 9 is all or nothing, you know. Not Java 9, but the whole module system thing. So as I said previously, you got a new release like Java 5 or Java 8, and it brought some cool new APIs, and you were free to try them out. You could adopt them slowly, maybe talk to your colleague and say, hey, how about we replace this for loop with a nice little stream? And then you gave it a try, and then you decided, okay, it's cool, we want to do this, or you said, okay, it's not for us, let's just stay with the loops, it's clearer for us, or whatever. So it was like opt-in. You were free to do it or not. But with the module system, as I said, you have to modularize your whole application. You cannot say, okay, let's just make this one thing, like the core thing is a module, and the rest is just like we did it before, like on the class path. Because everything has to run on the module path then. And here's a famous quote of a colleague of mine, Mark Phillip, who is the JUnit 5 project leader, and he said, so the module system is mainly interesting for people writing books about the module system, because if you think about it, what were Java developers asking for before Java 9? I can think of multi-line strings or value types or stuff like that. I can't remember a conversation where somebody said to me, you know what would be really cool if we had a module system in Java? That's really missing here. I mean, we already had OSGI. That was, I mean, you could use it, but if you like. I actually had to do it at my first company where we were building Eclipse applications, and OSGI is underneath of it. And I think OSGI it has its areas where it shines, although I don't know them. But there was a module system already, okay? So the question is, why should we do it? And this is actually the JetBrains, part of the JetBrains survey. So they're doing the surveys, I think every year or every half year, I don't know. And they're asking various questions. And one question is, which Java version you are using currently? I mean, it's not like representative for the whole ecosystem. It's just one survey. But I have seen other surveys that have kind of numbers that are going in the same direction. So people basically stayed on Java 8 because they don't know how to deal with this whole mess. And as you can see, Java 10 and 11 are becoming more popular, but Java 8 is still the thing. So let me just ask, who of you is still on Java 8? Okay, so who is not on Java 8? Okay, you're on Java 11, okay. 11? Okay. So, okay, who is on Java 11 and is using the module system? Okay. Okay, so Java 9 adoption in numbers, I guess we see it here. Okay, so now I talked about the problems that I see kind of. Let's discuss the challenges. And I have some voices from the community, just some things that I saw on Twitter. For example, this email by Paul Benedikt, who is a committer of the Groovy project. You don't have to read the text, but it's basically about, hey guys, so he wrote to the comments list and he said, hey guys, you are using this pattern of 1.x for the Java version. For example, in Commons Lang, there is a class that can pass this out for you, and then you have an API to ask it, which version am I running on? And he says, guys, do you know that they changed this? So it's now like 9.0.0 and not the 1.x anymore. And I mean, this email kind of shows that when you're providing APIs or frameworks or libraries, everything becomes an API. Even this one method that returns just a string saying, this is my version, becomes an API. Because if you change that, they changed it, stuff will break. Because people expect it to return this version number in a certain format. And actually, there were a few Apache projects affected by that. For example, Hadoop couldn't be run on Java 9 in the beginning because they were using this facility from Commons Lang that wasn't able of handling it. So we had to make another release to push this. And I think what's interesting here is I said in the beginning that they never did a breaking change. Although they had this marketing release numbers where they said, okay, this is Java 6 and this is Java 5, it will still report as a minor release. It will still report I'm Java 1.6 and I'm Java 1.7 and I'm Java 1.8. but now it's Java 9 and Java 10, so that they really reflect here, this is a major release, and we break stuff between major releases. Okay, so another voice from the community, something I saw a few weeks ago, somebody developing the equals verifier, which is a library to make sure your equals implementations work. And he's complaining about Travis CI because it's hard to get builds passing there because of the way they handle JDKs. And Travis CI, for you who don't know, is like a CI server as a service. And of course, if they want to support Java builds, they have to have some facilities to define which Java version you want to test against. And there are all sorts of problems. For example, you cannot forever download old Java versions. So sometime on the Oracle webpage, for example, the download links, they just don't work anymore. And I mean, you have to accept these licenses, and then you have to do hacks where you do a curl and pass some headers that say, okay, I'm really accepting this, I'm not a robot. And yeah, so he's complaining about that. And Sergey, who is, I think, now working at Pivotal on the Spring project. I'm not sure, but I think so. But he's famous for, or he's well known for his work on the test containers project. And he's talking about Gradle and saying, okay, Gradle doesn't work on JDK 13. Why is that? And it seems to be that there's RSM inside of Gradle. And with RSM is a bytecode generating language, so you can generate bytecode directly without having a source file and then compiling it. For ASM, the class number version, so there's basically an identifier in each class file that identifies the version of the compatibility of the class, so for which Java version it has been compiled. So if you compile something on, say, Java 11, and you try to run it on Java 8, the Java 8 will complain that it doesn't know this version. So it's like, I think, 52 or something. And of course, if you are a library like ASM, this also becomes your API. So really messy stuff. Okay, so people in the community, like myself, are seeing some problems with this. And I just listed it here for you again. So it's hard to stay compatible with different Java versions because, I mean, with the Apache Commons project, we create libraries that are really widely used everywhere around the place. And the last numbers I saw on Maven Central were that like the only project that is used more widely is the JUnit project, because everybody tests, but not everybody uses Apache Commons. Some people use Guava or both or whatever. So we want to support all those users, and they are running on all the different Java versions. It's really, really hard to test against old JDKs. For example, Commons logging is released targeting Java 1.2. I mean, I don't even have a Java 1.2 compiler on my machine. The oldest thing I have on my Mac is Java 1.6, and I'm not even sure you can get a Java 1.2 compiler for macOS somewhere. I don't know, does anybody know? Does anybody have such an old compiler? No? Oh. Sorry?
Windows or Linux, yes. Mac.
Yeah. So, I mean, that's not their fault. Maybe, yeah. I mean, yeah, whatever. So anyway, Commons logging is really like supporting really, 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 really old versions. And as you saw today in the panel, if there is security issue in Commons logging, we need to fix that. So we basically have to find out if it works on those old JDKs, because there might be some mainframe running somewhere with Java from 1999. You don't know. So, and as a core library, like Commons Lang, for example, you can't move fast and break things, because if you remove a method and people build their applications and they say, okay, I need Apache Commons lang 3.5 because I want to use that method, and then they have a transitive dependency to Apache Commons lang in another version, and their dependency, so the transitive dependency uses a method that's not there anymore in the newer release. It doesn't work. It's impossible to get it working. So this is why the Commons project is very, very conservative when developing or extending APIs. And I think I have this here a little bit more. So what we usually do is, if we ever decide to break our APIs, and we don't do that a lot, then we make sure that you can have the old version and the new version together on the flat class path. So what we will do is we will change the Maven coordinates. So because in Maven you can't have like the same two versions with the same coordinates. You cannot say I want to have foo version 1 and foo version 2. It has to have another artifact ID, so you can declare it both in the same POM. So we changed that, but that's not enough, because even if you could pull it in with Maven with different artifact IDs and versions, you would still have this clash on the class path. If this class is there 2 times, you don't know which one will win, the newer version or the older version. So we also moved the whole package to a new package name, and this is why most of you probably have org Apache Commons lang string utils and org Apache Commons lang 3 string utils. So you always have like these 2 versions, because the first is from the last release, release line, the 2.x line, and the later is from the 3.x line, which is the current line. So let me just reiterate, breaking changes, they have never happened before. So I mean, you could use libraries like Guava, where they had a more how do you say it, where they had a policy to break things sometimes, and that led to problems, and eventually they decided not to break things anymore. But you could trust your runtime. You knew, okay, this runtime is rock solid, there will never be a change. But this has changed now, so you cannot expect that anymore. So looking from a library author perspective, let's say we have this breaking change that I described before. If I'm writing a library and only my internals are affected, so they remove the method that I'm only using internally, I'm good. I can try to elevate that somehow, maybe by, I don't know, maybe by writing it some other way, but I'm able to fix it. But if it affects my public API, for example, because a class is removed, like date is a good candidate. I think date, it has 20 methods and 19 methods are deprecated because people realize it doesn't really work. So if that would be removed, it would be like, it's a problem. Because as I said, a breaking change in a library like Commons, it's a major undertaking. It's really a lot of work, so we don't do that often. Actually, I think we haven't done that for the whole time that I've been there. I joined the project, I think, in 2011 something, and that was by the time when we had Apache Commons lang 3.1. I can't remember being part of such a change. So yeah, module system, it seems to be hard, maybe even impossible to cross-compile. Because let's say I have Apache Commons lang and I want to be compatible with Java 8, but I also want to have a well-defined module for people running on Java 9 in the module system. So I would have to sneak this module info class into my jar, because I can't have like more than one jar on Maven Central, you know. And I'm not even sure if that will work. So if this module info class is there, will Java 8 load it, or will it say, okay, what the fuck is this? This is completely invalid. I don't know what to do with it. Has somebody tried that actually already? Trying to get a module info into a library that is supposed to run on Java 8. Is that possible? I don't know.
It is possible if you have combined
Okay.
You always have problems if you have runtime environments that scan the library.
Yeah.
Like Tommy is looking for annotation or something like that. There you get problems.
Ah, okay.
Compatibility then
Yeah.
doesn't expect two different in one jar file, two different class file versions.
Yeah. Okay.
This is very typical today to have some stuff to scan your classes for annotation. So
Okay.
99% of people use it.
Yeah.
Spring Boot or persistent mappers. And so
Yeah. That
it's
was
quite difficult.
okay. Another comment.
There's actually a way to do that theoretically, but it still breaks because of the same reason. So actually, that for example in Lucene we are also using is you can compile some classes with a newer Java version and put it in a subdirectory of the jar file, which is then a multi-release jar.
Okay.
So actually the Java 8 compiler won't, the Java 8 runtime would not see it at all. So you can also replace your classes. But the problem is if you have, so I think Android had a problem which was scanning whole jar files for annotations, and it didn't stop doing that at the meta-inf directory, which you should not enter. But in that case, it was also finding the class file, and that was breaking because of the bytecode format. So, but actually, the correct way to do that would be a multi-release jar.
Okay. So let me cross the impossible. It seems to be possible somehow, but you need to talk to the people in the last row because they are the magicians that know how to do it. So one fix you can do is introduce the automatic module name manifest header, and that basically generates like an artificial software module and says, okay, this is the module with this name, and everything is exposed. I mean, one of the benefits of the module system is that you can hide internal packages and internal APIs. So you couldn't use that with this solution. And actually, in Common Slang, we cannot really, I mean, we are using it. We have the automatic module name, but we have one method that kind of closed the Java 9 door for us. And this is it's this method in abstract circuit breaker. I mean, we could ask ourselves, why does a library like Common Slang need a circuit breaker? But okay, that's a different discussion. And as you can see, this is public API, and it gets a parameter, and it's a property change listener. And the unfortunate thing about this is property change listener is in the package Java Beans, and this is part of the Java desktop module. So what we were trying to fix was not having the desktop stuff in our server applications, but because we introduced this before the whole Java module system thing, we couldn't know that that this would be coming or will become a problem. So the idea basically is that you have the circuit breaker and you wanna observe the state and wanna maybe gather statistics or something, and for that you can register a property change listener. And now it's part of our public API, so we can't remove it anymore because there might be somebody using it. So if we define a module, it will always be a module that has the desktop module as a dependency. So we're back to the beginning again. So what now? How do we deal with this mess? Options for library authors that I see. You can stay with Java 8 because if you define the automatic module header, it will work on the module path, and I mean, your library might work on your Java versions, but you will run into this probably with the breaking changes in the runtime that you need to handle somehow. And the problem with this approach is if you're not keeping pace, you will eventually become irrelevant because people will say, okay, I mean, this is this old stuff from 2010. But currently, that's kind of the style that we're doing it at Apache Commons. So we are staying mostly on Java 8. Or you can try to go with the flow. But I think a lot of organizations are not ready for this fast pace of Java releases. And as we could see, the Java user base still seems to be on Java 8. So it makes sense to target Java 8. And if you go with the flow and with the releases and do that, it might require to introduce breaking changes into your library, which you don't really want. And getting ready for the module system with the library that was there before the module system is really hard. And I called this JUnit 5 style because they really do a lot in that direction and try out new features, and they have well-defined modules, and they test against different compiler versions, and so it's a little bit more fast-paced. So I honestly don't know. I don't know what to do with this. I've been thinking about this a long time, and I think it's a problem that you can't solve. You can't stay compatible with the old stuff if they say we might break the old stuff. So it's impossible, basically. So with that, to be honest, I have to open up the discussions, because maybe you have a good idea. So, but I don't have a solution today. I just can show you the challenges and the options that you have, but I don't have like this one answer, okay, do it like this way and you will never run into problems, because there is no easy answer to this. Yeah, and that's it. Thank you. Questions?
I have to mention there's another problem if you maintain a library that is based on reflection. So you have currently the problem if your application of your library is running in the automatic module or is a real module, which means the complete reflection code behaves differently. So you have the problem, you should test your library in both situations, and that's also a challenge. I don't know how to do this really automated today, even with Maven tools or something like that. There's no real support for this. It's another problem that we have from this module stuff.
More comments? All right. Then, okay.
I just see as a third possible option how to do. Perhaps we as Apache community can also talk to Java community or works more closely with Java community and convince that this way is not so optimal for the people. And regarding the model system, I also works a lot of with OSGI. In the past, was a strong believer in OSGI. So no, not anymore. But I see in some projects and some models they use OSGI very successfully. And the people who want to have modularization can have something more compatible with OSGI. But it's not for the 99% of the Java community.
Yeah, with regards to talking to the Java community process or things like that, I hope that they eventually realize what they did when they look at the numbers, because I mean, 83% still on Java 8. That should send a signal. But, okay, then that's another question.
There's one other thing. I wonder if I look at my own company, we have a code that is for more than 2 decades old.
Yeah.
So this old code is definitely not ready for module system. There are sometimes jar files with shared packages or something like that. The point is, it is a major effort to clean this up. A major effort that is not in any way funded by customers or something like that. They just see the product. They see the product should run on your Java versions, but the effort that is necessary to bring it to this, you don't get the money just out of your normal business. And I don't have a solution for that, because if I go to my chef and say, okay, we need a man's year of effort to bring our product to the new Java version, I know what happens. You say, no, that's not possible.
Yeah.
So I wonder what to do with this. I have no idea about that.
Yeah, it's definitely a challenge.
I'm not sure that Oracle are being that much worse than Sun on this. So I remember Apache Poi back in the day when Java 5 came out with the for each loop. One of the things in Apache Core, you want to loop over your spreadsheet. So we wanted to be able to implement the for each loop for rows and cells, but we were still compiling against Java 1.4 because that was the most popular JVM at the time. And when they brought in this new thing, it was iterable. So there was already the iterator, Java util iterator. They brought a new one, iterable. It wasn't possible to have it still compile against Java 1.4 and also expose this new feature. And so we ended up with a long time with everyone complaining because we hadn't upgraded. And then we did upgrade to Java 1.5, and then everyone complained because they couldn't run it anymore because they were still on 1.4. And that was back in the Sundays. And we shouted at them a bit, and they sort of shrugged and said, well, you know, why aren't you just on the new version? What are you going on about? And they were just thinking about the applications, not the library. So I don't think it's much worse. It's just still as terrible as it always has been for whatever it is, 15 years.
Okay, thank you.
We also have that question also in other libraries with the module system always coming, so people starting to complain. So for example, Apache Lucene is also having the problem of the shared packages. So you have multiple jar files with exactly the same package caused by some package private access and whatever. So you cannot easily detangle that. And then the people are complaining, and our answer to that is in most cases, if you want to use Lucene, just use our jar files, and before deploying your application in your module system, bundle everything together and declare it as one module in that, or maybe, so you can still use a module system in Java 11. You can use it, but you declare your whole application just as one module, which requires Java base and some other stuff. So that's only a workaround, but that's also always a problem, how to explain it to people.
Yeah.
Yes, so in my opinion, the only sense behind the modularization is that you can tell it, I want to have a smaller JDK that is shipped with my application, and I only want to have that modules and not the desktop environment. That's the only way that you can currently use it until everything in Maven Central is somehow working with that, which is impossible.
Yeah, in my opinion, there's a real value in upgrading to latest Java version because you get performance, better performance and security fixes. But a trade-off could be to stay at most compatible with Java 8, test against Java 11, be sure that your code can run on Java 11, 12, whatever. And be prepared and follow the flow of deprecation. This is a trade-off. You get the best performance. You know, hotspots is really changing the internals, the implementation. Okay, but okay, you can't use the coolest features because you can run them on JDK8.
Yeah. Okay. So thanks a lot for coming, and have a very nice conference.